So in the question it is given that u equal to x plus y divided by 1 minus xy and v equal to tan inverse x plus tan inverse y. We have to find out the Jacobian of u v with respect to xy. We know Jacobian u v with respect to xy, that is equal to partial derivative of u v with respect to xy, and in determinant form that is equal to determinant of partial derivative of u with respect to x, then partial derivative of u with respect to y, partial derivative of v with respect to x, partial derivative of v with respect to y. Suppose this is equation 1 and the value of u and v are given. So we will find out partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and partial derivative of v with respect to y, and you substitute here in the determinant. Then we will calculate the determinant, value of the determinant. It is given that u equal to x plus y divided by 1 minus xy. So partial derivative of u with respect to x, that will be equal to, it is a division function. So applying division rule, that is 1 minus xy into partial derivative of x plus y with respect to x minus x plus y into partial derivative of 1 minus xy with respect to x divided by 1 minus xy whole square. So if you solve it, then you will find that it will be equal to partial derivative of x plus y with respect to x, that is equal to 1. So 1 minus xy into 1 plus here x plus y, and partial derivative of 1 minus xy with respect to x, that is equal to minus y. So minus y, here minus, so plus y. So plus y into x plus y. Okay, x plus y divided by 1 minus xy in the denominator, 1 minus xy whole square. So you solve, if you solve it, in the numerator you have 1 minus xy plus xy plus y square divided by 1 minus xy whole square. So xy plus minus xy plus xy cancels. So in the numerator you have 1 plus y square divided by 1 minus xy square. So partial derivative of y u with respect to x is equal to 1 plus y square divided by 1 minus xy whole square. Now we'll find out partial derivative of u with respect to y. It is given that u equal to x plus y divided by 1 minus xy. So if you find out the partial derivative of u with respect to y, that is partial derivative of x plus y divided by 1 minus xy, applying the division rule, that will be equal to 1 minus xy into partial derivative of x plus y with respect to y minus x plus y partial derivative of 1 minus xy with respect to y divided by 1 minus xy whole square. So if you find out the solve it, that will be equal to 1 minus xy, and then partial derivative of xy with respect to y, and then that will be equal to 1. So 1 minus xy minus x plus y into partial derivative of 1 minus xy with respect to y, that is equal to minus x. So minus x plus y minus x, that will be equal to 1 minus xy. In the denominator you have 1 plus xy whole square. So in the numerator you have 1 minus xy minus, again minus, plus, so x into x square, x into y xy. So here you have 1 minus xy plus x square minus xy. So minus xy plus xy cancels. So x square divided by 1 minus xy whole square divided by 1 plus x square divided by 1 minus xy whole square. So partial derivative of u with respect to y, that is equal to 1 plus x square divided by 1 minus xy whole square. Then we will find out partial derivative of v with respect to x. It is given that v equal to tan inverse x plus tan inverse y. So partial derivative of v with respect to x, if you apply the inverse trigonometric function of tan, that is equal to 1 divided by 1 plus x square, and with respect to this, that will be equal to 0. So partial derivative of v with respect to x is equal to 1 by 1 plus x square. Similarly, partial derivative of v with respect to y will be equal to 1 by 1 plus y square. Now what we have got, partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and partial derivative of v with respect to y, that we will put in the determinant. That is, in equation 1, if you put these values, then Jacobian u v with respect to x y will be equal to 1 plus y square divided by 1 minus x plus y whole square. And then partial derivative of u with respect to y, we have found out 1 plus x square divided by 1 minus xy whole square. Partial derivative of v with respect to x, we have found out 1 divided by 1 plus x square. And partial derivative of v with respect to y, we have found out 1 divided by 1 plus y square. And if you find out the determinant, you see, I have found out here the determinant. Multiply 1 plus y square divided by 1 minus xy whole square with this. Then 1 minus y square, 1 plus y square, 1 plus y square cancel. So we have 1 divided by 1 minus xy. This 1 divided by 1 minus xy whole square. Similarly, if you multiply this with this, then 1 plus x square, 1 plus x square cancel. So minus 1 divided by 1 minus xy whole square. So this will cancel. So the answer will be equal to 0. So in this way, you can prove that if you have given the functions u equal to x plus y divided by 1 minus xy, v equal to tan inverse x plus tan inverse y, then you can find out easily the Jacobian of u v with respect to x, y. Thank you.